Hi, thank you so much for coming to our presentation at the Global Conference on Sustainability in Higher Education for us to present the MycHotel, a novel mycelial building material used to augment solitary bee and wasp conservation by Katie Ayers and Lauren Gillespie. Hi, I'm Dr. Lauren Gillespie, and I teach biology at Central Community College in Columbus, Nebraska. I am co-PI and program director of Project Growing Pathways to STEM, or Project GPS. This is a National Science Foundation funded STEM scholarship program through the STEM pipeline through NSF. And the S is for scholarship. So we are able to give scholarships to students to come to our college, and we provide them with special programming and access to the same types of on the job career skills that our students in our technical and career areas receive as part of their education, where in academic areas in community colleges, there's not as much focus as on the job training. And so as part of this program, we actually put students in the position to do active research and to be part of local industry tours and potential internships, paid internships at those industries as well. We also expose the students to multiple professional development activities, in addition to, as I said, active research topics. This is how Katie Ayers comes in. Katie Ayers is one of our GPS scholars, and she came into the program having already invented this mycelial building material and her process for making it, and brought this amazing project or possibility of projects to our program. And so we then, as she will tell you later, came up with the idea to make these bee hotels to see how this impacts bee conservation or health, as again, she'll tell you more about that. Our program is a really unique program at a community college because we have undergraduates doing active research. This project is absolutely incredible. It gives us the opportunity to give low-income students opportunities to pursue science as a career and to give them multiple areas of support with mentoring and, again, doing some active research, which is always exciting. So if you folks have questions about these types of grants, what pipeline this is, I'm happy to share my grant with you. I'm happy to talk more about Project GPS because this model we're really pitching as a national model for other community colleges and four-year colleges to take advantage of, to be able to provide undergraduate students with the best access to resources, especially in rural areas. So with all that being said, I will give it to Katie Ayers to take you away in talking about fungi and how she thinks fungi can help not only save bees, but save the world. And so hopefully by the end of this, you are a bit more excited about the possibilities of fungi and specifically some of the projects and ideas that Katie Ayers has come up with. So Katie, I'll have you.
As Dr. Gillespie mentioned, my name is Katie Ayers, and I'm a Growing Pathways to STEM scholar at Central Community College. I'm also the Students for Sustainability Club president and the Sustainability Professional intern on the Columbus campus. I'm a non-traditional college student with a fierce passion for all things fungi. Hopefully, by the end of this presentation, you will understand why fungi are so alluring from a sustainability standpoint. So let's jump right in, shall we? When you think of fungi, what comes to mind? If you're like most people, you probably thought of mushrooms. Mushrooms are actually just the fruiting body, and their sole purpose is reproduction, though. The main body of a fungus is a dense network of root-like filaments known as mycelium. The mycelium grows through organic material, breaking it down into smaller, more accessible molecules that can be utilized by plants, animals, and other microorganisms. But mycelium has many applications, including water and air filtration, bioremediation of harmful pollutants, and my favorite, building materials. I've used fungi as a building material in the past when I created the MyCanoe, an 8-foot fully functioning canoe. The canoe inspired me to keep building, and I created furniture, planters, and many other items. Then I read a study about a certain fungus and honeybees. This study, by Washington State University, showed that when honeybee colonies were given sugar water with the extracts of Ganoderma fungus, the bees showed a reduction in deformed wing virus and Lake Sinai virus. So this made me wonder, What about our native pollinators? Could this help them too? Many of our native pollinators are solitary bees and wasps. There's over 4,000 species of them in the United States alone. They get a bad rap because most people think that all bees sting. The truth is, solitary bees and wasps are gentle. They don't have a hive, so as long as you're not directly threatening their lives, they're probably going to leave you alone. These pollinators prefer cavity dwelling or laying their eggs in the holes found in trees, plant stems, or even in the ground. Humans can provide nesting cavities for native bees and wasps with traditional bee hotels. Generally, these are made of wood. In the cavity of these bee hotels, the bees will lay their eggs end to end in brood cells that they create using leaves. The bees make sure to place enough pollen to get each of their offspring from the egg to the pupal stage so that they can emerge the next spring or summer as a fully grown bee or wasp. So how do we know if the fungi are going to be a good option for the bee hotel? Well, after the myconu was successful, Dr. Gillespie and I were able to go to the University of Nebraska-Lincoln Nanoscience Center and utilize their scanning electron microscope. Under the scanning electron microscope, we saw that the material was completely non-porous. No wonder it was waterproof. But that isn't the only valuable quality of mycelium. It also has fireproof, antimicrobial, and anti-static characteristics that make it a great building material for many different items. That's when Dr. Gillespie and I decided to bring the concept to our GPS cohort. As a group, we started brainstorming ways to make the molds for the bee hotels, and we settled upon using cardboard boxes. We lined the boxes with plastic so that the mycelium would not grow through them, and then packed the mycelium and substrate into our makeshift molds. After about a week, I was able to start unboxing our creations, but unfortunately this was at the beginning of the initial stay-at-home order at the beginning of the pandemic. So I couldn't have others come to help me. I decided to make a video of the process. As you can see, I already cut open the outside box to reveal the inner portion of the actual bee hotel. I realized that I couldn't quite just pull the inner box out, so I ended up having to cut it and peel the plastic away from the mycelium. After it was completely unboxed, I put it into the homemade humidity chamber that you can see on the right side of the screen. We left it in there for one more week, and then it was time to take them out. After inserting cardboard tubes and adding wire mesh around the box, we had our first prototype. The MycHotel was mounted in our pollinator garden on campus, and after just a couple weeks, we had evidence of our first hotel guests. Now that we know that bees and wasps will nest in our mycotels, it's time to grow more and start collecting data. We hope to grow 30 mycotels by next spring and place them in different locations across central Nebraska. There are many different data points that could be collected. The one that is the most challenging given the nature of the study is how do we quantify the impact on the bees' health? If you have any ideas on how to quantify the rate of viruses impacting solitary bees or wasps, please let us know. Thank you so much for listening, and leave any questions or comments in the chat box. We'd love to hear from you. And now I'd like to leave you with a question. If you could build anything from mycelium, what would it be? Thank you.